Hello everyone. Am I clearly audible? I think so. Let me just check. Okay, let's see if things are working. Okay, let's get started. Hi everyone. Am I clearly audible? And are you guys able to hear me up? Quick message in the chat if things are working fine. Just maybe like a quick +1, anything, whatever comes into your mind. Yes. Okay. Good to see all of you back. Finally came back to Bangalore आज morning mostly. So now things will get back in shape. जो भी था पहले से हो रहा था. Last week full travel, right? Yes. Okay. So, sir, biweekly didn't go well. How many questions? Just good to see. I can recognize most of the faces or names actually. Faces, names. This is one sad thing about online teaching, right? Because you just get to know names instead of faces, which is not the real human connection per se, but quote unquote does work, does helps, but still. Yes, class कब से start है? So I think all of you guys would already know about the ICP starting from like first only. So the first class on the first, it will be just logistics and stuff, getting to know what to start with, and from second onwards you can assume like learning classes will start, right? Okay, good to have Nitish also on stream. कब से start होगा class and all for course? Yes, summers is going to be big. I think anybody who is joining in the camp, I'll make sure that like obviously it also depends on whether you are fully committed or not. Just my commitment wouldn't help, but then what we'll try to do is uh, will cover enough that is needed to cover till div 2 A B C in CF, and that should be good enough rating jump for your or most of you like on CF. Okay, chalo. Gukesh became chess. Yes. Gukesh ka to yaar, I think all of you guys would have been following. I mean, technically, even if somebody doesn't follow chess, they would know about results of Gukesh in India. That's a big deal. Okay. Timing of classes 8:30 onwards only at the night. Chalo ji, let's not spend too much time discussing about other things. Let's start with the discussion. Bi-weekly, how many questions were you able to solve in bi-weekly? In contest, obviously. कितने क्वेश्चन हो गए थे कॉन्टेस्ट में? So today we'll talk about bi-weekly and the weekly, both of them. Okay. 3 in both. Okay, good. 2, 2. Yeah. So summer camp is going to be in English itself. Yes. Like post classes, there might be some interaction here and there in Hindi, but the classes are going to be in proper English. 3, 2, 3, 3. Okay, nice. Okay. So let's start with bi-weekly. I think that's where things like we go in the chronological order possible. And I think this I can see the 7 pointer. So ideally, like would have been a little harder than usual. I mean, 6 stars, 6 pointers are simpler to solve comparatively than to 7 pointers, and 8 pointers have generally seen being solved by like double-digit numbers only. I think very few people were able to solve even the last problem over here, right? I was seeing the leaderboard. Okay, let's get started, right? So first problem, let's quickly jump through these because I know these are easy and you all would be able to solve it. But then let's, for the completeness of the like the session, just quickly go through them. So you are given a 2D matrix. 3 cross 3 contains of black and white. You have to change the color of at most one cell so that the matrix has a 2 cross 2 square where cells are of same color. Right. So so you basically have to make 4 of the cells having the same color. So essentially and at most one cell you can change. So essentially for any 2 cross 2 you have to check whether there are like 3 or 4 number of same colors or not, right? All 2 by 2 matrix, just check if it has 4 same colors or 3 same colors or not, because if that is the case, then you can change the 0 or 1, like whichever is not present, you can convert it to the color that is majority in that particular square, right? Does this make sense? And in fact, if I think about it, there are very few matrices which will not be, right? I mean, if I think about it, either it will be this, or it will be this line, or it will be this line. I think from my like understanding, I'll just quickly open up the drawing pad. I think there are only three possibilities of not having, or sorry, not three, four maybe. Four. There are only few ideas that will not generate. Let's try to think about that direction also, because I mean I know that you guys can solve it now, but let's try to learn any new other idea that might possibly be there. So how many 3 cross 3 you can think of which will definitely lead to like having no solution? I mean, if you have this, um, like over here in this 2 cross 2, either it will be these two as the same color or this two as the same color, right? So when you have this 2 cross 2, this 2 cross 2, both of them has different, and now in this case you can have one over here or some sort of one over here, right? Okay. So either it will be like a line or this line, or it will be this. There are only few, but I guess there are too many, so you don't want to write that code. I was thinking if there would be only 2 or 3 cases, then I would have written just that check. But yeah, in this case, you can loop over through cross 2 cells and check how many blacks and whites are there. If any of them is 3 or 4, you are done, or else if none of them has that. If all of them are equal, then it's not. All go through all 2 cross 2. If all of them have equal, that means all of them has 2 white, 2 black. Because if anything changes apart from it, either one of them will be 3 or 4. So they have to be equally balanced. So if all of them are 2 cross 2 are equal, then you say you can't, or else that's there. Yeah, 2 rows, 2 columns. Yeah, this 2 row, 2 column, 2 row, 2 column, 2 row, 2 column. Right? Every 2 cross 2. Clear? This is one simple strategy. The board could have been a little bigger, but they just gave a very simple problem, I guess. Move to the next problem. Quick +1. Let's move to the next one. फटाफट बता दो यार. Let's quickly drop into +1. Can we can check diagonal? Yeah, you can do that also. Okay, chalo. First problem, super simple. I think you guys might not be even interested in discussing this. Chalo, let's move to the next one. That would be way more interesting. But what if we got bigger board? We can't do brute force, right? Yeah, so in that case, you'll have to have some idea. There is a very interesting problem. So, given a big board, check every k cross k if like they have equal number of ones and zeros. So that you need to do some sort of prefix sums. I don't know if you know about 2D prefix sums at this point in time or not, but 2D prefix sums can help you in that case, right? For 2D bigger boards. Yeah, perfect. If you don't know that, like the link to generally the content would be there. The prefix sum content is there on bang.in, so you can check it out. Okay. Great. Chalo, next one. Right triangles. Given too many grids today. सभी मैट्रिक्स आ रहा है मेरे को दिख रहा है जितना. Everything is matrix. Return an integer where the number of triangles can be made with three grid, so that all three of them have one value. Okay. Nice. The prefix sum would work. You would have made some mistake, or कुछ भी possible. Okay. So this is exactly how you need to find number of triangles. Okay, so we essentially are looking for like this. So whenever you have to count triangles, whenever you have to count anything, you need to know the pivot by which you are iterating on things, right? this is the thing that I will be having constant, and then like try to count the number of other things that you can take, right? So triangular prefix sum, ये सब नहीं use करना, you don't need it. That's there in the video, but you don't need it. In this case, you just need to count, like use this pivot, right? That hey, this particular point is the right, like the corner, right angle triangles corners, and then check the number of ones that are over in this row and this column. So if you can build the number of rows and number of ones in every row and number of ones in every column, then for every one you can choose number of row ones in that row minus 1 multiplied by number of ones in that column minus 1. Does that make sense? If this is the pivot of the right angle triangle, which means the right angle part, then any of the ones in the row can be the one leg, and the others, and anyone in the column other than it can be its one leg. So simply just count the number of ones in each row and column. I'll just take this one example so that we are clear. 1 1 1 0 0 0 1 0 0. For every row you can sum up 2 1 1. This is 3 1 3 0 1, and then now go through every cell. Okay, now go through every cell. For this cell, the number of possible legs on this same column is 3 minus 1, because this has already been taken. So 3 minus 1 multiplied by this, in this leg 2 minus 1, okay, plus any for every I comma j, for every I comma j which is there, it will be number of columns. I don't, in fact in this case it's just this. In general it will be nothing but ri minus 1 multiplied by r column j minus 1, right? The summation of this particular thing, isn't it? R of I minus j if I comma j is a of I comma j is 1, right? For every cell which is 1, which can be the leg, the number, every one in that same row is a possible leg, every one in the column is a possible leg, and multiply them and you will get this. This is the expression that you need to evaluate in this case. So simply loop and pre-calculate the number of ones in rows and columns. Either we take two consecutive grids with one left and one right to make it time, which is right to one. Yes. Does this make sense? Is this idea clear to everyone? Can I have a quick +1 if this is making sense? कि भाई इधर choose करो, एक इधर choose करो. So 2 choices, either 1 choice, 2 into 1. Expression is nothing but, yeah, this is the point, no? So this is the, if I comma j is the one that I'm pivoting it on, the right angle on that same row, all the ones can be feasible except itself. So r minus 1, c minus 1. In the column also it can be other egg. It can be above also, but it doesn't matter, right? And then this multiplication for all different cells, because all of them can be possibly a right angle, given that it's a 1. Okay, so this is the expression for it. Clear? Second problem clear to everyone? I think straightforward, but again, it's a good problem. You need to do this. Left side maybe 1 honge to also make triangle. No? Yes, yes. So when I'm saying right, so if you have 1 1 1 1 1, when you select this, the number of ones in this ri minus 1 3 minus 1 is nothing but either this or this. So it's actually trying to choose on both the sides. It's not like I'm choosing only downwards or this side. Okay, this ri minus 1 can also take backwards. It's in the same row, not necessarily down or right. Okay, so that is why it is important. Okay. Clear. Chalo. Next, let's move to the next problem then. Let's see what was the next one. Right. So if you're on the stream, like give it a like quickly so that it reaches to a few more people who might be interested in Leetcode discussion. I know very few people are in general. Upsolving, everybody loves to know कि upsolving करना है, but करना बहुत कम लोगों को actually. Okay, that's the reality if you think about it. So it's always like attend these and then complete the code. Even if you don't attend, make sure that you go ahead and code the solutions after learning it, right? It's super important. That's where you grow. There are only two parts where you grow. When you are thinking about the solution, initially when you are coding it also, and the third is when you are actually solving it after knowing the idea. चलो next देखते क्या है. I have not seen the problem. अच्छा, this is similar to the fourth one. I have seen the fourth वाला question once. So some people are saying कि नहीं हुआ मेरे से, तो भाई ऐसे कैसे नहीं हुआ. So Chanchu reached out morning कि ये वाला problem fourth वाला नहीं बना था. तो ऐसा क्या आ गया? So Chanchu is helping me on snippets and stuff. I'll show you the codes also of these problems. I think Chanchu had already sent me those on the chat. So the last problem, I think there is simple. There is nothing much to show in terms of code. So I'll just quickly show that. Yeah, one count in row, one count in one. So it's like straightforward. Okay, great. Chalo, let's move to the next one. So from what I'm assuming, this and the last problem is same. This is the normal version. I have seen this problem before in like CodeChef and on Algorithm. Both of it is the same problem that is present in both the sites. I've seen this problem before, exact same problem. How many of you had seen the exact same idea before? Because in DP problems, no, these state ideas you need to have seen before. That is how you generally solve harder DP problems. है ना? क्या देखा है ये सेम प्रॉब्लम देखा है कि नहीं देखा, पहले ये बताओ मेरे को. Yes or no? No. This is called, this was on Code Forces, Knights and Horses या Knights and Legends करके कुछ प्रॉब्लम था. I don't know. I have seen this problem before. Exact same problem. How is that possible? यार यही है, सब कॉपी पेस्ट ही होता है, इधर उधर लग रहा है. But anyways, I'll, no matter if it is or if it is not, it doesn't matter much. You need to be able to solve it with or without knowing it. Okay. ठीक है. I'll anyways like start discussing this. 200 into 200 into 400 into इतने सारे कैसे आ गए, बाप रे बाप. How is this many coming? 200 into 400 कहाँ से? अच्छा okay, ith one. So number of ones, number of zeros, limit is 200. 3 कैसे हो गया? 2 होना चाहिए था ना. डीपी तो यार I've already taught डीपी में मैं कुछ अलग नहीं सोचूंगा. देखो ध्यान से सुनो. So let's next Miss by 30 minutes is again the revision of master class of DP जो मैंने already DP workshop वगैरह में cover करा ही है. But listen to me very very carefully. ठीक है. ठीक है. This is a very very fundamental problem of DP. ये अगर solve नहीं हो रहा है means you have weakness in your DP. मतलब मैं ये नहीं बोल रहा हूँ second problem part solve हो. Optimization करना is not easy. But this problem you should be able to solve if you know how to manage states. ठीक है. This is something I've even taught in my workshop कि जो like YouTube पे भी है, you manage DP states, you basically build DP states for two specific things. One, किस form का है? How many of you know forms? How many of you don't know forms -1? That is more important. ठीक है. I mean, I know that you might have tried and learned maybe DP from somewhere else, ठीक है, and it's good. I generally suggest कि basic DSA तुम्हें कहीं से सीख लेना चाहिए. But then on my content, I have taught more advanced things. मतलब advanced thing कुछ नहीं है, more things in the sense that how to think about it. वो चीज एक बार सीखो because that will help you get better in terms of thinking of problems. So in this case, what you need to do is you need to think about which form this problem is in. Getting TLE on 2000, 2000, 2000. Okay, in that case, then Leetcode is weird. 2003 should have worked ideally, yeah, from my understanding. I don't think that generally gets steely. But ठीक है, anyways, let's try to solve the problem. उससे ज़्यादा मैं क्या ही करूँगा. But if I would have read this problem and then I would have read the problem too, and I would have thought कि यार ये तो दोनों same problem है, I would have solved only this problem, right? So that is generally how I think about problems, that ऊपर वाले solve करना, because I have to solve all problems, right? Yeah. या टाइप पास तो कर जाना चाहिए था. There is something then issue. We'll see. So you are given a like 3 integers, this exactly 1 zeros, this. Okay. So firstly, when you read such problems of DP, what do you? No, not that problem. There is knights and legend. I'll just quickly search. Code force big problem hai. Knights and legends. I don't know. DP. If I remember this correctly. नहीं ये नहीं है. कुछ तो भी था एक problem. I forgot. Most probably if Nitish is on chat, he can send me. I'll. There is a famous problem. ठीक है. But उसमें क्या होता है? You basically have this limit कि you have to place. There is n positions. You have to place knights on that. x1 knights of type 1, x2 knights of type 2. No, not more than k1 number of knights together of type 1. No more than k2 number of knights together of type 2. This is exact problem of code forces. ठीक है. I've seen this problem before. So वही है कि you need to have seen similar ideas before. But even if you don't know it, right, how do you solve such problems? The idea for this generally comes from the constraint that is there. कि हमें क्या बोला गया है? I'll just quickly screenshot it off because I don't want to switch too many times. The question is saying that we need to basically place these things. ठीक है? इनको हमें place कर रहे हैं, and we need to be able to find the number of ways. Okay. Now, as soon as you read the constraints being 200 or 1000, DP should click, because if it was possible to solve it with maths, they would have given like 10 to the power 5, right? So kuch to bhi DP hai. I mean, maths most probably is not there. So my first thought would generally be ki let's try to think about this problem in terms of DP. Then I would see the constraints. There are 2 types of constraints. One is the constraints that is there in the limits of the values, which is obviously important. 200. One is 200, version 1. Version 2 has up till 1000, right? So I see the constraint values. And the second thing is the constraint. The question is saying that I have to create an array with like number of zeros plus number of ones. It's like this. There are x number of seeds, or not really x, I'll say x number of seeds, which is nothing but 0 plus 1. You have to place this many zeros and this many ones in this, right? Something like this, right? Or there is x positions, place zeros and ones. But why is everything not feasible? What, like, you have to just place zeros and ones. Why is everything not feasible? Number 1 constraint. Number of occurrences of 0 in ARR is exactly 0. So there is constraint 1. Everything is not feasible because number of ones, zeros, has to be exactly equal to 0. This is a constraint given to us, and that is why all 2 to the power x is not feasible. This is how you think about DP problems. Next, number 2 constraint is the number of occurrences of 1 in the array is exactly equal to 1. So number of ones is equal to 1. This is again another constraint. Okay. Third, each subarray of array greater than this must contain both zeros and ones. Third kya hai? So this is a very like twisty term, right? This is a twisty term. Ki each subarray. I don't know how to manage all subarrays and stuff, right? So let's try to understand what this third constraint is saying. Each subarray of array of size greater than limit must contain both 0 and 1. So if you ever have a size of limit plus 1, okay, that means it has to has 1 0 and 1 1. So if you have been placing bunch of zeros, if you have placed limit number of zeros, you cannot place one more 0 because that will make this condition fail. So this condition is just saying you can have maximum continuous streak, how many values can be continuously same, is nothing but equal, is has to be less than equal to the limit given to us. This is very very important to decode कि इसका मतलब क्या था, what is the meaning of this particular statement, that each subarray of array has to be each subarray greater than this limit. So anything that goes more should have at least one that is not same as the other, right? So this is what you have as constraints. ये समझ में आया कि these are the three key constraints that is limiting all the 2 to the power x solutions. We could have filled 0 and 1 anywhere, right? All the things. But there are three constraints to be respected. समझ में आ गया ये चीज? Yes or no? Quickly. Is this clear? Once you have your constraint set, then you think about, okay, Vivek, I have my constraint set. Which form do I put this in? Memset करोगे तो then it will TL. You don't want to use memset in your recursion. You don't want to do memset and stuff. Let the recursion flow, and whichever states can be reached, it will automatically fill those values only. I'll teach you how to do it without using memset also, maybe once. The number of occurrences of this. Okay. I don't know why it's giving TLE. I'll have to see. Maybe somebody can send me why did it get TLE'd. It shouldn't. Okay. So over here, number of zeros, number of ones, max continuous streaks, these are limits. So first to detect the form, this is simple steps that we do in every DP problem. Form detection. So I can fill this, each position is 0 or 1, and it's like building sort of, I can say, what do you say? A sequence of zeros and ones, and every element needs to be chosen. So it can be form 1, or you can also try to model this in form 2. Ki, acha, I have to fill all these with zeros and ones. So how many of the last will be similar one, and what to use, or things like that, right? Something like that might also be possibly be used. Okay, so both form 1, form 2 should be possible to use in this problem. Yeah, but ideally this should be take, not take. You should be able to solve it with take, not take. So let's try it with form 1, no problem. So if you have form 1, you will then next step 2 will be to write the zeros, the states dp of what and what do I return. The question asks find the number of ways, total number of ways. So we will return the number of ways. Form 1 by default comes till index I and fills the rest. So number of ways to fill from I till n, and over here we have the state form. Okay. And then you need to put in more things to manage these. Number of zeros has to be exactly equal to k. So number 0, how many zeros you have taken till now. This is obviously important, because you need to make sure, right, that number of zeros is exactly equal to k. So you need to track how many zeros have you taken till now and how many more will you take, right? Then you would have number of ones that you have taken till now, right? This is to track this. And max continuous streak, right? So in this case, we need to maintain key whatever was the last value and what was the streak, maybe till how much it was continuing. So if you had 0, 0, 0, and you are filling over here, so and there was ones in front of it, so you will maintain that last value was 0 and the streak was of length 4, right? So last value like 0 or 1 and the streak length. This is something you can keep in states. Does this make sense? How are we maintaining this? The last which value was there and this the like streak length, because then if you place a 0, you'll have to check, right, that now the streak length will become 5. Is 5 even allowed? Yes or no? You'll have to think about it. If you put a 1, then the streak length will reset to a 1. So that you also again need to check as you go forward, right? So this is super interesting. I mean, if you think about it, this is fairly interesting way to think about the problem. Great. So now this is something that is done. With this states, it should be solvable. Should be solvable in terms of DP. Now TLE is another reason. I'll think about why this is getting TLE once I've formulated it perfectly. So once this is done, 3, you will write the transitions. Hey, I have filled this much. The last value was 0, 0. I'm just assuming the last value was 0, but it could have been anything, and there were some number of them. So from over here, I'm at index I and I'm filling this value right now, and I have to go till n minus 1. So I have to write the transition for this. So dp of I comma number of 1, number of 0. I'm just writing n1 and 0 quickly to see this. Yeah, I is the pause. I is the position that you are currently in. Okay. Yeah, I'm coming to that. I'm coming to that. We can reduce all these things. We can reduce all these things. I know. I know. I'm coming to that. Let's first build the solution. No? So I n1 n2, and then you have like how many last values were same last streak, and then value last value. Yeah, these things you are maintaining. So now you can figure out कि भाई, if I put a 0 over here, like I'm assuming that last value was 0, so you can either go to dp of I comma n1 comma n0, but since you put a 0 over here, maybe you'll get something like this, and last streak will increase by 1, and last value will remain same. Last value will be 0, but it increased by 1. Or maybe I'll go to I plus 1, sorry, I plus 1. Either now you will place a 1, so number of ones will increase, number of 0. Yeah, we'll do bunch of cloning and stuff, don't worry. But now you have a 1 and you have went to this state I plus 1. So for you the last element was 1, and it has appeared only 1 times as of now. These are two transitions that can possibly be there, right? Similar kind of thing you have to write. Does this make sense, that this is sort of transition that we are looking at? Yes or no? Clear? Okay. So then you realize that, okay, Vivek, will my time limit, the fourth step is time TL check. Okay, will this even pass? I see that this is 400, like number of positions is 400, 200, 200, 200. This is too much, right? How you got state idea? Because of these constraints. No? You need to know that how to manage these constraints. This is something you need to know. This is how you practice. How to manage these constraints using states is something, each constraint is mapped to a state idea. You need to know how to map each constraint ideas. TL check, too much, I think. 400 into 200. I'll just write it. Assuming that everything is limited till n, this is n into n into n into n into 2, which is too much, right? Can you give tabulation solution? No, I don't know how to write tabulation solution. I mean, I can solve anything, but I don't solve in tabulation format for at least starting off the solutions. Because as long as you don't need optimizations, I don't go into iterative coding in general. I mean, I can go in anywhere, but you should not. Then you realize that, okay, it is always true that the number of zeros that you have placed plus number of ones is equal to number of I. Will this always be true? Because this will at start with 0, 0, 0. If you place a 1, it will be 1, 1. Then it will place a this will become 2, so on. So will this always be true? Yes or no? Right? So this is called state space reduction, right? I hope you know the term. I had already mentioned it in the 6th wala Deka video. कि when you have relations between the state values that are there and you can always derive one from the others, you can just drop it. You don't need it because I is always equal to this. So if you don't need to keep this in DP, right? And you can just build with this. कि भाई पता है मुझे I is equal to n1 plus n, so you just don't need that in DP at all. Okay. From this I can figure out which index I am currently putting value on. So now this removes one of the n's and you have n cube into 2 kind of solution, which ideally should pass the first part, because 200 cube into 2 is fine. How much it is? Is it 1.6 into 10 to the power 7, I guess? 10 to the power 6. 10 to the power 6 and this is 16. So 1.6 into 10 to the power 7. This should pass. But then it's Leetcode. So you'll have tons of problems because they run multiple times and they have no strict, like every run of program should be there. Okay. So if this didn't pass, then I guess it's a then मेरा हो गया था pass. हाँ वही मतलब there has to be some pass. So Saurav, if you have it, maybe send me the code on Leetcode. Yeah, sorry, on LinkedIn once अभी के लिए वही खुला हुआ है. So ठीक है. हाँ. I think they didn't want n to the power 4 to pass, and that's why they might have made it super hard. Okay. Possibly. Okay. But yeah, like I think desired solution is this only. I don't think that the desired solution would be of lesser complexity for the first part. Clear? हम लोग second part ही solve करते हैं. I mean that will also pass for the first part most probably. ठीक है? Second part solve कर लेंगे तो first part तो solve हो ही जाएगा. I mean, don't get disheartened because of not being able to solve the first part. ये चीज कभी कभी लीड कोड पे होता है, बट अंडरस्टैंड दैट इफ यू आर रियली गुड यू शुड हैव बीन एबल टू सॉल्व द सेकंड पार्ट. सो सेकंड पार्ट सॉल्व हो जाए तो ही आप अच्छा कर रहे हो, नहीं तो फिर इतना जरूरत नहीं है कुछ. ठीक है. आई वांट टू जॉइन प्रीमियम. अभी तो प्रीमियम स्टार्ट भी नहीं हो रहा है. मे बी यू विल गेट सम डिस्काउंट लेटर ऑन. अभी तो ऐसा कुछ नहीं है दैट आई नो ऑफ. ठीक है. सो प्लीज यूज योर पावर. यार देखो, आई कैन टेल यू लाइक अ वेरी इंपॉर्टेंट ट्रूथ. जैसे आई हैव ट्राइड टू कीप माई सेल्फ डिटैच फ्रॉम ऑल द लाइक डिसीजंस ऑफ प्राइसिंग एंड स्टफ फ्रॉम ऑफ एजेड. आई मोस्टली कीप माई सेल्फ ऑन कंटेंट. क्या पढ़ाया जाएगा, क्या कंटेंट होगा, साइट पे कैसे कंटेंट काम करेगा, सम टेक एंड स्टफ, बट ऑल दीज थिंग्स. बट हाँ, मतलब डिस्काउंट कूपन आई कैन ट्राई. रीच आउट टू मी ऑन लिंक्डइन, आई कैन ट्राई वंस. ठीक है. यार शक्तियों का गलत इस्तेमाल करने बोल रहे हो तो मुझे. हाँ. ओके. स्लैक पे भेज दिया हूँ B4 में. ओके, आई विल सी. चैट ही खोल दे रहा हूँ मैं. ओके, सौरभ का कोड देख लेते हैं. अच्छा, तुम लोगों ने ये 2 स्वैप करके देखा? सामने 2 करने से क्या पता पास कर जाए. Did you guys know this? I don't know if you know this or not. This is fairly interesting. Sometimes this I'll just send it on the Slack, on the like YouTube पे, chat पे, that having smaller states before in the matrices helps you get the codes accepted when the states are getting faster. Okay, DP of this worked for me. Yeah, these are just bogus stuff. ठीक है ना. ये सब करके अगर पास भी करा लेते ऐसा कुछ है नहीं, बट कुछ नहीं कर सकते. ठीक है. I mean, this is also an art actually to get it passed. This is basic. So when you move it in forward, right? So there is cache benefits of having all the values of L1 when you're computing something in the cache. ठीक है. So it just helps. एंड आई फॉरगॉट द एग्जैक्ट टर्म, मतलब वही है कि वो वैल्यूज लोडेड रहते हैं, ठीक है, नेबरिंग वैल्यूज जो होते हैं वो लोडेड होते हैं, सो हैव द स्मॉलर वैल्यूज इन फ्रंट. हाउ टू एलिमिनेट द अदर स्टेट्स फॉर हार्ड वर्जन, यस वी आर कमिंग टू दैट. ये सेम प्रॉब्लम मैंने करा रखा है, हाउ टू एलिमिनेट द सेकंड स्टेट, बताता हूँ अभी, ठीक है. दिस इज एन ऑप्टिमाइजेशन प्रॉब्लम, इसलिए डीपी ऑप्टिमाइजेशन बहुत बार आता है यार. डीपी ऑप्टिमाइजेशन इज लाइक इज फेयरली कॉमन, है ना. जैसे if I ask you that there are only like few number of DP optimizations and more ideas also, but prefix sum based DP optimization is very very common. कि यार एक state drop करो and then try to make it like prefix optimization supply मतलब problem optimized, right? This is fairly common. So I'll just move to how to do this. Vector was giving TLE but array fast. ये भी true होता है कि array ज़्यादा fast होता है, ये तो सत्य है ना. But if we cube 2 by the first and the other 200 at the end, will it be good there also? Yeah, it is good. It is good. The idea is for these three values, like then you are using all the values over here. So that's the thing that generally gets helped. और तो कुछ फायदा नहीं होता है. But actually recursive में इतना help होना भी नहीं चाहिए इसके वजह से. But it just works. When you are writing iterative code, it helps much more. Okay. Chalo, and I think we do not want to discuss bogus optimizations at this point in time. Let's understand how to solve it in a perfect way for the fourth problem. Cache coherence. Search कर सकते हो ये word. I have forgotten the word. उससे भी TLE आया. Okay. Reduce the number of modulos in your code. That is also another important part. I don't know if you guys know this or not, but modulo is fairly expensive. Okay. So if you have used too much of modulo in your code, reduce it. Like he has used, so think about this code. It's just doing modulo once in all of his code. So that's super important. Okay. Yeah, I promise. Okay. Slow operation, yes. Modulo is super slow. Divisions and modulos are super slow operation compared to others. I mean, it's order one only, but the difference would be significant between a plus and a modulo. Okay, so next let's move to the optimization wala part, because I don't want to teach how to make it optimize and stuff. So next fourth पे move करें. Third का idea समझ में आएगा. This idea is clear? Yes or no? Okay. So now when you think about this particular problem, there is very little you can do to optimize it, right? Because transitions are only two, okay? And the states are over here. And from our discussion, we already know that all states are important, because why is every state important? Because each state is doing something of its own, right? This is helping us manage this. This is helping us manage this. This is helping us manage the next one, right? So all the states has its purpose, and we cannot really drop anything magically, right? So it's fairly difficult to do an optimization from over here. So how do you then optimize it? So generally what I've seen is, when you start with a problem, right, that I have to reduce the time complexity of a DP problem, first think about its state optimizations. कि यार मैं क्या state drop कर सकता हूँ, like this one. Can I drop this state over here? Okay, you think about its state optimizations. Then you try to think about transition optimizations. Can I optimize my transitions? But there are only two. What to optimize over here? Then you try to think about, if none of them is true, you try to think about, can I throw certain states as a transition instead of states? Because keeping it in states will force us to use it in memory. We'll have to create the memory for it, and there is no more scope of optimization, right? So can I convert some state into a transition, possibly transition, right? That is what I generally think about. So the idea is, think about State optimizations. There are many state optimization ideas that exist. Like you think about state space reduction, you think about possibly better representations of certain constraints. Then you possibly think about uh, ideas like sorting, and that's like doing some sorting or some sort of operation that makes one of the state vanish. Things like that exist. Then you move to transit optimizations, that there are prefix sums, there are data structure maintenance and stuff like that. But then when both of them fails, what you think about is, can I convert some states into transition, because I cannot do any of it without it. Okay. So yeah, so it just makes the space reduced firstly, plus it allows us to do possibly transition optimizations later on. Yeah, the time remains same, but possibly we can think about more of like transition optimizations if we have that transition, right? अभी तो दो ही है, तो दो में what will you optimize? But if there are n and then you can do it in order one, then possibly there is some sort of possibility, right? So that is how you think about it. So what you do is you like think about what can be converted. ठीक है, देखो, दिस इज अ डायरेक्ट कंस्ट्रेंट कि भाई ये इक्वल होना चाहिए, काउंटर तो रखना ही पड़ेगा, देयर इज नो अदर वे, देयर इज अ डायरेक्ट कंस्ट्रेंट, काउंटर रखना ही पड़ेगा, राइट? बट देन वी कैन ट्राई टू थिंक अबाउट दिस प्रॉब्लम फ्रॉम अ डिफरेंट लेंस, एक्चुअली फ्रॉम फॉर्म टू लेंस, and it might throw this off the state parameters. Okay, my personal advice, when you are thinking of keeping higher transitions and lower states, always think in terms of form 2. Why? Remember, form 1 में क्या होता था, you just decide for each one of them you have two choices. Form 2, sorry, form 1 में, form 2, for each you have O of n transitions, but then you have dp of just I, right? Something like this, if you remember, that you have O of n transitions but you have a single I. Does this make sense, that dp of ending where it's ending, and from I you just have bunch of this, right? Yeah, so instead of uh, keeping it in form 1, when you want more transitions to happen, move it to form 2. So we will again think about this problem from the lens of point form 2. We have already understood this idea, now we want to do it in form 2. How do you do it? So there is a sequence which you have to make, which contains of length, let's suppose I want to make dp of x comma y, or n0 comma n1. It should contain this many zeros and this many number of ones. Okay, so the length is n0 plus n1, obviously, exactly it's this. And then maybe I'll try to figure out that, hey, how many sequence contains n0 zeros and n1 ones, which ends at a 0. Okay, and does not contain sequence with n0 zeros, n1 ones, ending at 0 with less than equal to limit continuous sequences, right? And now when you think about this, you suddenly see that you can always design a transition the way we do it in form 2. Look at the ending value and how long does it continue, right? That's how we do it in form 2. Form 2, how many of you are able to get the idea कि transition कैसे लिखेंगे form 2 में? How will we write the transition? That for the ending element, see how long it will go continuously. The last partition, इंटीग्रेशन, ये क्या होता है भाई? इंटीग्रेशन नहीं आता मेरे को, इंटीग्रेशन क्या होता है? वैसे ही हुआ ना. So in form 2 we used to take the last partition and group it together. That is what generally we do in form 2. So over here also we will do the same thing, that भाई ये form last वाले element को देखो, this is going to continue from here till certain point, like up till a certain point, and this length cannot be more than this limit, which is a constant value, right? So till this much, whatever like x number of zeros you place over here, then you will move to dp of n0 minus x, n0, just a sec. Why is this not changing? N1 1 ठीक है, x number of zeros बैठा दिया, अब 1 बैठाना है, and I have this as a sequence. This is the state I will go to if I place x zeros, है ना? But then this x can have like limit number of transitions, like either you have 1 or 2 or 3 or up till limit. But now we have lesser states and more transitions. Does this make sense? X matlab some x, I don't know how many x, but some number of x, because the last element is zeros and we can continuously place bunch of zeros, right? Because that is the restriction on कि कितने zeros हो सकते हैं. So we'll iterate on that. Does this make sense? कि ये जो sequence बना रहे हैं, so the sequence we are building is nothing but this, right? Bunch of ones, bunch of zeros, bunch of ones, bunch of zeros, something like this. It's ending with 0. Find these partitions. Like we are trying to partition an array such that उसमें any partition is less than equal to k limit, and the sum of zeros and ones are managed. So this is how you design transitions from to, right? कि last वाला partition कितना बड़ा होगा, फिर next partition कितना होगा, फिर next partition कितना होगा, and things like this. So what we are saying, if the last element is zeros, how many zeros were you actually placing before the last one? And we know that it cannot be more than the limit. So let's say you place x number of zeros at the end. So from this state, if you have x number of zeros at the end, where x can be in the range 1 till limit, because if you can only go till limit number of zeros, because if you do limit plus 1, the constraint will fail. So in that case, we will have this new state which we will reach. कि भाई हमने x number of zeros बैठाया, so now this many zeros are left, this many ones are left, and now you have to place ones. How many of you are clear with this particular DP state transition idea? This is form 2 thinking. This switching you will have to understand. Why did we switch number 1 and how are we designing this switch? कि हमें एक total n0 plus n1 number of banana hai. We have to fill how many ending parts are 0 continuously. We are iterating on that. Clear everyone? और फिर उसके बाद bunch of ones होगा, फिर bunch of zeros होगा, फिर bunch of ones होगा, and so on. अरे हाँ या ना, समझ में आया नहीं आया? हाँ, the complexity is same only. See about this, you will have this constraint is n2, and earlier the transitions were 2, but now the transitions are n. So it is O of n cube only still now. But it is better in terms of memory. Till 1 to limit, yes. Does this make sense to everyone? ये clear हुआ? क्योंकि हम लोग x number of zeros बैठा रहे हैं ना, so number of same values cannot be more than limit. That's the thing. That's what's mentioned. Okay. अभी भी n cube है, but it's a little better solution, and I think this will pass easily. अगर मैं इसको code करूँगा, this will pass in the 3rd version very easily. But then this will not pass in the 4th version because like 1000 cube will not pass for sure. The constraints are very, very, like the number of states are very small, the transitions are clean, so like this code will pass much easier than the previous one. Okay, so क्या हमें बना, like the rule is prefer form 2 if possible. Yes or no? ये समझ में आया? I mean both works, but prefer form 2 if feasible. Okay, I also do this sometimes when I'm undecisive between the two. Form 1 is simpler to think and it solves most of the problems, but then prefer form 2 when you can do it if it's optimizations and stuff. Okay, now once this is done, we now need to see how can we make it faster. And this is where DP optimization comes into picture. We cannot reduce the states, we can only reduce the transitions. So what is happening? Okay, I'm assuming DP of x comma y comma 0, like the last element has to be 0, इसका हम कुछ form कर रहे हैं. So this is x, this is y, and you have to have, this is the cell which you are filling, this is the zero layer, the zero value layers. ठीक है? So when you are finding the dp of x comma y comma 0, what do you need? It depends on dp of x minus कुछ k number of मैंने zeros बैठाया है. So this y and 1, this is the state which you will reach. So you will reach to the state of 1. So it's not in the same rectangle, it's in the different, it's in a different rectangle. So let's go back a little bit and let's draw true rectangles. ठीक है? This is dp of x comma y comma 1 rectangle. इसमें सारे dp वैल्यू स्टोर हो रहे हैं, इसमें सारे जीरो वाले स्टोर हो रहे हैं, राइट? So when you are calculating dp of x comma y comma 0, you need dp of x minus k. So this was x minus k. So this is y. This is the corresponding cell over here. Okay? But you don't need this. You need dp of x minus 1 comma y. I'll use another color. हमको क्या चाहिए यहाँ पर? dp of x1 minus 1 comma y comma 1. ठीक है? और this x minus 2 up till x minus limit x minus 1. To calculate this particular cell, what you are doing is nothing but you are looping through and summing just these values. No, कि भाई either एक 0 होगा, so you will get to dp of x minus 1 comma y comma 1, और दो 0 होगा, so you will go to 2 3, but there will be something like this, and इनके sum से ये sum बन रहा है, like the sum of these values is nothing but this. Yes or no? अरे हाँ या ना बताओ फटाफट. डीपी टेबल देखना आता है तुम लोग को? ऐसे दिखता है, ऐसे करके विजुअलाइजेशन होता है? I don't know if you guys are able to visualize DP tables at this point in time or not. But whenever I need to design transition optimizations, I always draw these tables. Where is the DP values being stored and what are they actually accessing to find its value? The transition is nothing but sum of all these values. Okay? So this needs these values to be calculated and you need this sum. ठीक है? तो ये बनाना पड़ेगा तुम्हें खुद से. For what do we need for dp of x comma y comma 1? भाई एंड में 1 आना चाहिए, तो हो सकता है assume करते k number of 1s आएगा. So you will get dp of, you will need the values of, in fact the value of this is nothing but sum of x minus y minus k. The number of 1s will reduce by k and you are placing k number of 1s and you will go to this state. How does that look in this diagram? What are these states? इनका सम चाहिए. सम से कैसे भैया? अरे काउंटिंग जब करते हैं, व्हेन यू काउंट, तो क्या करते हो? यहाँ पर क्या था? यहाँ भी तो सम ही था. जब भी तुम्हें लाइक whichever configurations you go to find the number of ways there, इनको सम ही तो करना होता है. जब काउंटिंग करते हैं there is always a sum. ठीक है? Whenever you are calculating this and you can possibly go to bunch of configurations, वहां से जितने ways है सबको add करने से you will get your current ways कि यहाँ से कितने ways थे. So over here यहाँ पर तुम 1 2 3 डाल सकते हो. 1 डाल के जितने वेज प्लस 2 डाल के जितने वेज प्लस 3 डाल के जितने वेज, राइट? दैट इज हाउ यू काउंट. ठीक है? यहाँ पर भी हम वही कर रहे हैं. एक 0 डाल के जितने वेज कि यहाँ 1 होगा, फिर 2 zeros डाल के जितने वेज कि यहाँ 1 होगा, फिर 3 zeros डाल के जितने वेज कि यहाँ 1 होगा, ऐसे करके ये सारे काउंट कर रहे हैं. एंड सबका सम ही तो होगा, लाइक ऑल पॉसिबल कॉम्बिनेशंस ऑफ दिस. सो यू सम देम अप टुगेदर. क्लियर? ऑब्वियसली हम थोड़ा हार्डर टेरिटरी में जा रहे हैं, बट समझना तो पड़ेगा ही एट द एंड ऑफ द डे इंप्रूव करने के लिए. क्लियर है यहाँ तक कि भाई इनका सम आ रहा है हमारा, ये चीज सम, ये सम समझना पड़ेगा सबसे पहले. तो ट्रांजिशन है ये तो नॉर्मल सा, ये तो बिना उसके ट्रांजिशन है ऑप्टिमाइजेशन के. अब कितने लोग ये क्वेश्चन कर लेंगे ये डायग्राम बनाने के बाद? क्या लगता है? इफ इज इट पॉसिबल नाउ? यस और नो? नो तो लिखो, कोई तो नो लिखो। कैसे हो गया सब कुछ? कैसे हो गया डायग्राम बनाने से? I mean, just by the virtue of creating this diagram shouldn't make everybody be able to solve this. कोई तो नो लिखो. How is everybody able to solve it? Huh? Yes. So for this particular, so to calculate, so whenever we are at some x comma y, इसका 0 and इसका 1 calculate करने के लिए we will need this sum and this sum fast. How to do it? Simply for this particular table, build like row, like prefix sums row wise, and for this table build prefix sum column wise. अब बोले विवेक ये कैसे होता है? ये तो पता नहीं कर पाएंगे, नहीं कर पाएंगे. रेक्टेंगल्स के प्रीफिक्स सम निकालना आता है. हाउ डू यू फाइंड द सम ऑफ रेक्टेंगल्स वेरी फास्ट? नहीं, उतना करने की भी जरूरत नहीं है. तुम पूरा 2D प्रीफिक्स सम याद है? देयर इज अ टेक्निक कॉल्ड 2D प्रीफिक्स सम. अरे भाई, एक रेक्टेंगल का, एक पूरे रेक्टेंगल में इसका सम चाहिए होता है. तो ये इस ये माइनस ये माइनस ये प्लस ये करते हैं कुछ, तो भी ऐसा कुछ करते हैं, समथिंग लाइक दैट, है ना? तो इसमें भी हम वही बिल्ड करते चलेंगे. 2D प्रीफिक्स हम बिल्ड करते हुए आगे बढ़ते रहेंगे. दैट वी कैन सिंपली फिगर आउट दिस माइनस दिस, तो ये पार्ट हट गया इसमें से, एंड देन सबट्रैक्ट दिस मच, तो ये हट गया, बट ये 2 बार हट गया तो इसको प्लस कर देंगे. समथिंग लाइक दिस वी कैन कीप बिल्डिंग. So as you are iteratively building this, keep building the 2D prefix sum also, and then you can find these values super fast. विवेक कोड कैसे होगा? करके दिखेगा कोड थोड़ा सा. हमको सिंगल रो सिंगल कॉलम चाहिए, बट ऐसे दोनों के लिए अलग अलग बिल्ड करना बहुत ही ऐसे वियर्ड हो जाएगा, राइट? मतलब दोनों में, मतलब यू कैन बिल्ड इट पॉसिबली, आई एम नॉट सेइंग दैट यू कैन नॉट, बट दोनों में लाइक बिल्ड करना डिफिकल्ट हो जाएगा कोड वाइज. सो व्हाट आई विल डू इज आई विल जस्ट सिंपली बिल्ड नॉर्मल 2D prefix sum, and that enables me to find both of them together, no, with the same piece of code. अरे तो सिंगल कॉलम का सम एक रेक्टेंगल ही तो है. वी डोंट नीड ओनली दैट. वी कैन यूज द जेनरिक वाला थिंग टू सॉल्व सिंगल रो सिंगल कॉलम आल्सो. हाँ. So let's see how do we do these kind of problems. So I'll code this problem. Okay, I'll code this problem so that you guys are clear on how to write such weird iterative codes. Maybe आ गया भाई code question. No, not this. This, है ना? Okay, so how do you figure this out? So let's quickly write some piece of code so that we are able to solve these problems. And integer limit I'll pass. So there's zeros and ones that you need. You are anyways passing it over here, right? So I'll just write integer recurrence, integer 0, integer. So this is n0, n1, integer 2. This is the last val, 0 or 1, right? This is what we told as a recurrence, right? And then we will try to loop through the limit value. So I'm also passing the limit, but it is just a passed value. I mean, it is not being used anywhere. Okay, I'll just keep, yeah, or you can also make it a constant outside, right here. Recurrence of, I need this many number of zeros, this many number of ones, and the last value is 0, plus recurrence of, I need this many number of zeros, this many number of ones, and the last value is 1. Either of the two is possible, and then we can just add them and return. Note that you should not forget the modulo at the very end. So we need a modulo also. Integer mod is equal to 1e9 plus 7. Right? This is something that will be important. Yeah, the clear? Everybody clear till this point? And we just need to write this recurrence somehow to be able to solve the problem with memoization, obviously. Yeah, the clear है? Yes or no? अरे भाई बताओ, इसमें तो कोई दिक्कत नहीं होनी चाहिए. यहाँ तक तो कुछ ट्रिक भी नहीं था, अभी तो कुछ लिखा ही नहीं है. Clear till this much? Quickly. Next. Then transition, and then save and return. This is how you write codes for DP. I'll build the DP array and maybe pass it separately in the function, or I'll make it globally over here. Okay. So let's say we'll build it later on. ठीक है, पहले normal recursion करते हैं. So you have a pruning. I don't have a pruning in this case. If n0 is equal to 0 and n1 is equal to 1, n1 equal to 0, then all the zeros and ones have been placed. So there is exactly one way. This is the base case for counting problems, that whenever you have no, like all things are filled, so there is exactly one way. Okay. So you return this. Cache check, we'll write it later when we make it a DP. You can actually write just normal brute force, right, recursion, and solve it, and then add a DP to it just to see. Once it's correct, then only you will add DP to it. I generally do it very often. Transition, because I don't want to waste time, right? Sometimes, I mean, doesn't happen at my level, but like if you find something is wrong with your recursion, then you can correct first and then add DP and stuff. So transition is integer answer is the number of ways to fill. For integer k equal to 0, k is either you place 1, k is less than equal to limit, k limit, k plus plus. You will put k number of the last character same number of times. So if last val is equal to 0. So one thing I can assume, if the number of ones, if n0 is less than 0 or n1 is less than 0, then return 0, right? Simply that. If it is less, then there is no possibility. I mean, we have put more zeros than needed. So I'll just loop through all the limits, and then simply if it's the large value is 0, then answer plus equals to recurrence of, you're putting k number of zeros. So n0 minus k comma n1 comma, now the number to be put is 1. Okay. Else this. And obviously by at the end of this we need to take modulo and stuff. So right, and then return answer. That should be basic recursion. Like you don't need more than this to check actually if your code is working fine or not. Let's run on sample. What did I write wrong? Oh, this should be this minus k. There has to be some way, right? Okay. Let's see. Limit is 2. K limit. Oh, this should be 0. Perfect. मैंने बस copy paste किया था, right? So it's working fine. It's working in terms of recursion, but it is not the optimized solution, but it is correct. So this tells me like most probably this code is correct, right? Now I can go ahead and add DP to it to make it better. Okay, but yeah, let's actually move this problem to the previous one because I think that will get accepted. So I know. It's the same complexity as the previous one. So let's see if that gets accepted. Medium one, and then we'll optimize it further. I don't know, yaar, what rating. I have no idea, absolutely. So I'll just have vector. There is a 3D array, right? Like two this. So what I do is I'll just do like one thing you can do is I'll teach you a trick for Leetcode. Sometimes this helps. Is you can maintain the integer DP array here, and I know 200, 200, 200. But then their code runs multiple times. So what I'll do is integer like done array, something like this. Okay. That hey, is this state actually saved for me? Like, is this state currently correct for whatever I've done? Is this state calculated? That is something I can maintain in a separate Boolean array. Okay. So this basically takes off the responsibility of this array being -1 if it is not calculated, and then value if it is calculated. If this is 0, then it's incorrect. If it is not calculated, if it is 1, then the value saved is correct. That's how it works. Okay. Now what I'll do is every time I get this, I know that I'm gonna need the states till this much. So for integer I equal to 0, I is less than equal to 0, I plus plus. For integer j equal to 0, j is less than equal to 1, j plus plus. For integer k equal to 0, k is less than limit k plus plus. Please don't use memset when there are multiple test cases running. It just makes it fail. K is less than 2, no? Done of I comma j comma k is equal to 0. Okay, this is something that you can write. It's not done, and then you call the recursion. So if it is to check if done n0 n1 last val, then return the saved value. If not, then done. Now it's done. The DP of this is nothing but this. Is it now visible? This should be visible. Clear? 3. Sorry, 3. Why even 3? Why not 2? Right. Okay, it runs on this. Is this the medium one? Let's try and submit. Let's see if after memoizing the result it works. So it gets accepted. I know, it gets accepted. Okay, so this is for the medium limit and cube wala thing. This much is the code. There's nothing much to write if you think about it. Why do we don't want to use memset? Because the way Leetcode tests is for each test case they give some small values, and then for few of them they give the large values, right? So they just call this function multiple times. Now if you do the memset for such big arrays, even for small inputs, then your code will really because resetting it will now become like a big task. Resetting 200 size array, even if the number of ones is 10. Okay, if both of these are tens, then this is super small, right? So that's the reason. Memset depends on the size of the global array. Okay. So this is how you think about it in terms of like solving the problem. But then now we need to optimize it further. But does this make sense? Yes or no? So we'll do transient optimization in recursion. I'll show you. I don't think I've covered that on YouTube, but let's see. I have covered it in classes, me said, but I've not covered it on YouTube. Let's learn that. Okay, let's see. Is there any difference in this code and this code? I think no. Okay, no difference. Is it possible? हाँ possible है, सब possible है. ठीक है. So let's try to minimize this function. ठीक है. So essentially there is this function which has now been memoized. ध्यान से सुनो, ध्यान से सुनो. तुम्हें क्या पता है उससे नहीं होता है. जो पॉसिबल है वो सुनो. ठीक है. So do you realize the true power of dp? Dp just basically makes this function now order 1. How many of you agree with this? That dp makes a function called order 1 because the values have been memoized, right? So now what we can possibly do is we can build another dp, okay, which will help us do prefix sum, okay, on this recurrence value itself. Okay, it will give us the prefix sum of n, like what is the prefix sum from the 0 comma 0 comma this to that. How to do it? Very simple. I mean the transition would be like this only. Like it will be this particular cell, ठीक है, plus the prefix sum, जो तुम लिखते हो 2D prefix sum of n0 minus 1 comma n1 comma last val plus अरे रुको तो भाई, तुम लोग क्यों टेंशन ले रहे हो? मैं जब कर रहा हूँ तो वो करेगा ना काम, क्यों नहीं करेगा भाई? जब मैं लिख रहा हूँ तो तुम्हें नहीं समझ में आ रहा है कि ये क्यों काम. मैं बताऊंगा ऑब्वियसली, I'll explain you why this will work. मैजिक बस, ठीक है, क्योंकि मैं लिख रहा हूँ इसलिए it should make sense. So but तो समझ में आ रहा है? This is, everybody agrees that this is how you build normal prefix sum, कि भाई इस this cell plus, I'll go back if you don't know prefix sum. The way you build for every cell the prefix sum from the start till this much is the value of this cell plus this whole thing plus this whole thing minus this because it has been added twice, right? ये पूरा plus ये पूरा minus ये एक बार, तो ये बाकी का part दे देता है plus this one piece. That is how you build prefix sum of this particular cell, right? And let's memorize this in another dp, that this is another dp part, like this is another dp function which we just need to know. So this prefix sum is also a recursive function. If n0 is less than 0 or n1 is less than 0, we just return 0. It's not feasible. If is there any base case? I don't think there is this base case, right? There's no base case in this case. Cache check if integer prefix 202202, ठीक है. If prefix of n0 n1 last val is not equal to -1, I'm using the traditional wala way. Right, this is how you write the recursion, right? No base case. Pruning, base case is not needed for prefix sum because it just gets the value directly from here. Single value will get its value, and these will all by default, by the virtue of pruning, will become 0. So this will get the first cell. so it will work. And if it is already saved, then it will just return. So prefix sums also needs to be made as prefix I comma j comma k is equal to -1. You could have done like the previous wala part also using just a dp array. Okay, I was just showing this to you all. If you want, you can do the normal wala thing also here also. Okay, that hey, this is equal to -1. um, like just do this. Okay, this is also like good enough, the way you do it usually, right? This is also going to work, no problem. But I just showed you another way to remove the dependency on dp array using a separate done array if you want to do it ever again. भैया भी लाइक आपको नीचे भगवान, हाँ मतलब मैं जो करूंगा वो अपने आप सही हो जाएगा, पता नहीं क्यों. नहीं ऐसा नहीं है, मैं भी गलतियां करता हूँ. एनीवेज, this is there, this is there, this is there. हाँ चलो ठीक है. So this should be the prefix sum of this particular last val from start to end. So now I am gonna go over here. So this is a prefix sum array. To calculate a particular value, I need the sum of a certain like things, right? So मुझे sum किस चीज का चाहिए? Instead of this, I'll write it over here. See. So this function is dependent on this function, and this function will get dependent on this function. Let's see how. So I'll say, भाई मुझे क्या चाहिए देखो, n0-1, n0-2, n0-3 up till n0 minus limit. Okay, k limit. So this loop I don't want anymore. One more thing I forgot. Please make sure to put all of these in modulo. And since everything is an integer, 2 at a time is super important. This bogus stuff, but क्या कर सकते हैं. Boring stuff, but ठीक है, कुछ कर नहीं सकते इस चीज का. Just to make it positive. या अभी पॉजिटिव करने की जरूरत नहीं, छोड़ो. ठीक है, this is something we just maintain in prefix sum, and then we don't want a loop over here. लूप नहीं करना है हमें. आई नीड दिस वैल्यू इन वन गो. ठीक है, ये जो वैल्यू है यहाँ पर, आई नीड दिस वैल्यू इन वन गो इंस्टेड ऑफ लूपिंग. सो इफ लास्ट वैल इज इक्वल टू 0, द रेंज इज, देखो मेरे को क्या चाहिए, आई नीड द सम ऑफ रेकरेंस n0-1 से लेकर के n0-k तक. ठीक है, n0-k से लेकर n0-k लिमिट से लेकर के n0-1 तक. the y will be fixed n1 to n1 and z is fixed 1. ठीक है, इसका मुझे सम चाहिए, इस रेंज का पूरा सम चाहिए, सारे रेकरेंस का देखो सम हो रहा है यहाँ लूप चला करके. so to get this sum I will use prefix sums on the array. so answer will be equal to prefix, कुछ नहीं करना है, जो prefix sum बनाया उसको यूज करो the way we normally use 2D prefix sums. prefix sum of जो भी बड़ा है ये होता है ना, this 1 minus prefix sum of this. So this is both inclusive. ठीक है, तो यहाँ तक जाना है, so I need to subtract -1 from it, n1 1 answer minus equals to दिस इज बेसिकली नॉर्मल प्रीफिक्स सम जो तुम लोग लिखते हो ना, प्रीफिक्स सम टाइप का कुछ कुछ, दिस इज एग्जैक्टली दैट. ओके, just that I have now added bunch of modulo and ठीक है. So this is essentially finding the loop of adding these values of recurrences using prefix sum, which is essentially nothing but prefix sum of the array. ठीक है, this is something which we are using over here. In case this is else, if it is for 1, then we will need a different set of loops. अगर 1 के लिए निकालना है, so I need to figure out what will be the range for ones. So ones के लिए this will be n0 to n0 only. It will be n1 minus 1 से लेकर के n1 minus k limit तक. Right, this is the rectangle that I need to find, whose sum I am required to use. So I'll just use 2D prefix sum to calculate that sum. These are this. ठीक है, ये n1 minus 1 से लेकर के so n0 n1 n0 n1 minus limit minus 1 n0 minus 1 n1 minus 1 and then both of these minus. मतलब वो जो 2D रेक्टेंगल का सम निकाल रहे हैं हम 2D में. ठीक है, इम्प्लीमेंट ये भी कुछ नहीं है यार. अगर मैं इसका फंक्शन बनाता तो इट हैव बीन वे इजियर कि गिव मी द रेक्टेंगल सम ऑफ दिस z x डॉट डॉट इन अ रेंज एंड y डॉट डॉट इन अ रेंज. बस दोनों को मैंने एक ही चीज लिखा है, इसमें कुछ लिखा नहीं है मैंने टेक्निकली. ठीक है, गिव मी द रेक्टेंगल सम ऑफ दिस, दैट इज व्हाट आई एम फाइंडिंग ओवर हियर. ओके, सो yeah, that should be there. Once this is done, I don't think we need to do anything more. Just run. कुछ तो भी इतना बड़ा लिखा है तो कुछ तो गलत करूंगा ही मैं. टेस्ट केस पे तो सही दे रहा है somehow. Okay, some large case modulo mistakes. Makes sense. This, so the values are too many negatives. Coming to that, answer equal to this. There are two mistakes. One's answer plus mod, because since the prefix sums, like there are too many things happening and we can have intermediate negative values, so we need to make it positive. Number one. Second is these values now need to be 1000. Right, and then let's try to run it again. Compile error. Okay. Probably plus mod then mod करना होगा. Right, correct. है ना? So let's try and submit. Yeah, gets accepted. Feels 100%. पता नहीं क्या लिखा है मैंने, but anyways whatever it is. विवेक, ये क्या करा आपने, समझ में तो नहीं आया, बट अच्छा लग रहा है कुछ. समझना क्या किया मैंने, इतना कैसे, क्यों ये पहले से किया हुआ होना चाहिए. मतलब ये चीज प्रीफिक्स सम्स का आइडिया पहले से पता होना चाहिए. यहाँ पर मैंने कुछ नया नहीं लिखा है. दिस इज अ वेरी डायरेक्ट आइडिया. यू कैन डू इट इटरेटिवली इवन फास्टर देन दिस. मोस्ट प्रोबब्ली आई कैन पॉसिबली डू इट इवन फास्टर देन दिस इटरेटिवली, बट आई वांटेड टू शो यू द रिकर्सिव अप्रोच कि कभी कभी रिकर्शन लिख लिया तो चेंज करने का मन नहीं कर रहा. सो आई राइट जस्ट अनदर रिकर्शन टू डू द प्रीफिक्स सम एंड यूज इट टू बिल्ड द आंसर. ठीक है, एसी लाने का तरीका थोड़ा कैजुअल है या बैंगलोर में मुझे लगता है एसी लाना पड़ेगा. बैक इन बैंगलोर गर्मी तो हो गई है भाई थोड़ी, बट हाँ ऐसा इंप्रूव करो यार तुम लोग. प्रैक्टिस हो तो हो जाएगा, नहीं तो कोड करने में गलती 100%। नहीं यार, मतलब देखो, आई ट्राई टू बी वेरी वेरी like cautious about what I write every time, because I know once I've written it तो गलत हो जाएगा. So while writing, you have to make sure that you are writing it correctly in the first go itself. ठीक है? So the way you do it is you essentially write things correctly in the first go. कि जैसे मैंने यहाँ पर ये लिख लिया, I wrote it for a reason. मैं तुम्हें दिखाने के लिए नहीं लिखा हूँ मैं ये चीज़. I've written it so that I don't make a mistake कि भाई ये rectangle का sum चाहिए. So it's R1, C1, R, C, फिर like this is nothing but R, X minus 1, X1 minus 1, वो मैंने लिखा है बस यहाँ पर. I'm writing these things to make sure that I don't make a mistake. ठीक है? So write these things when you are writing your code. It will help you. ठीक है? Plus बाकी तो prefix sums वगैरह तो I think like it's pure practice. The same piece of code I think I would have written multiple times by now. That's why I'm able to write it correctly. Sheer amount of practice that makes you get really good at accuracy in writing code. It's sheer number of problems. In that to topic wise, मतलब डीपी क्योंकि मैंने ये बार बार लिखा है तो इसलिए मुझसे ये क्वेश्चन सॉल्व हो जाएगा, राइट? हाँ भाई, मैं तो बोलता हूँ, आई ऑलवेज टेल अबाउट दिस कि यू शुड ट्राई टू स्टील द स्टाइल ऑफ राइटिंग कोड्स, ट्राई टू स्टील द वे समवन थिंक्स. ठीक है? हाँ, एजे में तो मैंने करा ही रखा है ये क्वेश्चन, वो तो मैं जानता हूँ. उनसे जिनसे नहीं बना ये देखने के बाद उनको तो मजा आना चाहिए कि भाई ये क्वेश्चन तो पता, इस टाइप का तो बता रखा है मैंने, ये प्रीफिक्स सम वाले ऑप्टिमाइजेशंस. बस पता है कि मुझे टेस्ट में इंप्लीमेंट नहीं हुआ होगा, वो मैं जानता हूँ. दिस वाज हार्ड टू इंप्लीमेंट इन कॉन्टेस्ट, क्योंकि सेकंड वाला प्रॉब्लम थर्ड करोगे, फिर फोर्थ में ये तुमसे अगर नहीं चमका एक बार में तो फिर मुश्किल है. बट ये जो आइडिया, ये तो मैंने 4 बार कोड करके दिखा दिया है हम लोग को, है ना? तो जिसने देखा था उससे नहीं बना तो फिर तो मुश्किल है. मतलब समझ के तो बन जाएगा, बट दिस वाज नॉट इजी एट द स्टार्ट. ऐसे आइडियाज देख रखे हमने, तब भी बनाओ भाई, क्या कर रहे हो? तभी तो सिखाया है सब ताकि फोर्थ वाला बने. हाँ वही, अरे द टाइम इज लिटिल लेस फॉर समबडी at your level to be able to solve this. It will need you at least an hour, and most people would not have left with an hour to code. So I am writing it faster, I can do it in less time, but you will not be able to do it in less time because I have seen the question before. No, Caesar and Knights, the problem on code forces is called, I just remembered, Caesar and Knights. Is that the problem? DP. Caesar's Legion, if I remember it correctly. क्या ये प्रॉब्लम था? मेरे को याद आ रहा है नाम. हाँ यही है. This is the problem on CF, which has very similar problem, which is N1 footman, N2 horseman. तुम्हें not beautiful if there is strictly more than K1 footman नहीं होना चाहिए, K2 इतना नहीं होना चाहिए. Design this DP. This was smaller constraint, but in AZ I had solved the harder one. तो इसलिए मुझे याद है कि ये कर सकते हो. But technically you would have known this if you would have solved these problems. ठीक है? ये मैंने कब सॉल्व किया? 2018 में सॉल्व किया था मैंने ये सेम आइडिया. But I remember names and problems in ways that people don't most probably. क्योंकि मैंने पढ़ा भी रखा है ना बार बार इस सेम चीज़ को. हाँ, इस पे भी वही आइडिया था. सेम ही है, देखो लूप सेम है, सेम लूप आइडिया. समझ में आ रहा है? हाँ मतलब लीड कोड पे तो स्टैंडर्ड ही रहेगा. हाउ डू इवन रिमेंबर द ओल्ड प्रॉब्लम्स एंड इवन नेम्स? बिकॉज आई रिमेंबर गुड प्रॉब्लम्स, है ना? देखो रैंडमली ऐसे याद आ जाते हैं, पता नहीं कैसे. देयर इज लाइक गुड लॉट ऑफ गुड प्रॉब्लम्स ऑन CF जो मुझसे नहीं बना था फर्स्ट टाइम में, या मुझे अच्छा कुछ सीखने को मिला था. दिस इज द फर्स्ट टाइम वेयर आई लर्नड अबाउट सच स्टेट्स इन DP कि दोनों का स्टेट रख दो. एंड मुझसे ये नहीं बना था एक बार में खुद से एज अ थॉट. सो आई remember the problems I couldn't solve myself. That's the only thing. जो भी प्रॉब्लम मुझसे नहीं बना है वो मुझे याद रहता है मोस्टली. अब कब तक याद रहता है वो अलग बात है, राइट. क्लियर. Plus, this was also part of A2, which is diff to D ladder. That's why I remember it. This was, I think, the second problem. The first problem was also of DP called flowers. करके नाम है, मेरे को याद आ रहा है. पेटिया and flowers करके नाम होगा शायद इसका. Anyways, let's move forward. समझ में आ गया ये चीज पूरा पूरा? कोई नहीं भाई, ऐसा बनेंगे, धीरे धीरे हो जाएगा. यू आर स्लोली एसिमुलेटिंग दीज आइडियाज, राइट. तो समझ में धीरे धीरे, एक दिन में तुम ऐसे नहीं बन जाओगे. इट हैज टेकन मी 3 years टू बी ओवर हियर, मतलब एट दिस लेवल. तो एक दिन में अगर ऐसे तुमको लगेगा कि एक महीने प्रैक्टिस कर लूँ मैं बन जाऊंगा ऐसा, फोन इम्पॉसिबल है वो चीज. इट टेक्स ब्रेन टू एसिमुलेट एनी आइडिया यू लर्न. हाँ, ये सब तो करते ही है, इससे हार्ड ही है सब. इफ यू विल आस्क मी व्हाट लाइक आई हैव सॉल्व्ड, मतलब कैसे कैसे टाइप कर रहते हैं, मतलब इससे हार्ड ही रहते हैं कुछ कुछ आइडियाज जो है, मतलब जो ऑप्टिमाइजेशन वाले आइडियाज है. अगर तुम लोग को एक होमवर्क प्रॉब्लम चाहिए, आई कैन गिव यू गाइस अ होमवर्क प्रॉब्लम ऑप्टिमाइजेशन में. दिस वन इज फेयरली ब्यूटीफुल. ये प्रॉब्लम ट्राई करना. आई थिंक ये तुम लोग को, ये दूसरा आइडिया है. ये भी सिमिलर आइडिया होगा, प्रीफिक्स सम वाला आइडिया. दिस इज आल्सो एग्जैक्ट सेम आइडिया कि प्रीफिक्स सम चाहिए इसमें. इसको भी तक लोगों ने सॉल्व नहीं किया होगा. कर लिया, नाइस. हाँ, दिस इज आल्सो प्रीफिक्स सम वाला आइडिया और 2 रखने वाला आइडिया. So I'm just searching for one problem which I want to give you guys as practice. मुझे तो पुराने साइट पे ढूंढना पड़ेगा. ठीक है, ये वाला क्वेश्चन कर सकते हो. यू कैन रीड दिस प्रॉब्लम लेटर वंस एंड ट्राई दिस. दिस इज अ गुड प्रॉब्लम, वेरी सिमिलर टू दिस वन. एक बार सोचना है इसके बारे में, ठीक है. लाइक गो बैक इन वीडियो एंड वॉच दिस क्वेश्चन. चलो, लेट्स क्विकली रैप द नेक्स्ट पार्ट यार. लेट्स क्विकली रैप द लीड कोड का अदर वाला कॉन्टेस्ट, और एल्स हम डिस्कस करते रह जाएंगे एंड टाइम खत्म हो जाएगा. Travel optimization is also very beautiful, but I have covered that in the day 6 video of YouTube, so you can learn from there. That's also a very beautiful problem. Chalo, let's move to the call the contest, weekly contest. फटाफट रैप अप करते हैं इसको, ठीक है. यार ये तो सेम प्रॉब्लम करा रखा है यार. कितने लोगों से ये बन गया था 4th प्रॉब्लम यार. जल्दी पहले फर्स्ट कर लेते हैं. चलो 3 ही है, तो आई विल जस्ट क्विकली ब्रश पास देम. आई डोंट थिंक वी नीड टू डिस्कस. अच्छा, फर्स्ट कर लोगे तुम लोग? फर्स्ट सेकंड कर लोगे? ये तो कुछ करने का नहीं लग रहा है मुझे. तुम लोग कर ही लोगे मेरे को लगता है. सीधा लास्ट पे चले क्या लगता है? Should we move to the last problem first? Then क्योंकि थोड़ा टाइम कम है, so maybe I'll discuss the last problem, third one and last problem. ठीक है, पहले लास्ट प्रॉब्लम कर लेते हैं and then third problem करते हैं, ठीक है. That way it will be faster. Okay. So you are given in this uniqueness of this array. In other words, the sorted array comprises of distinct of range L to R. Here distinct denotes the number of distinct elements. Median of uniqueness of numbers array. Note the median of the array is defined as the middle element of the array when sorted in this distinct elements. Median of uniqueness array. Uniqueness क्या है? Uniqueness array of numbers is sorted array. All सब arrays. Okay. भाई ये क्वेश्चन देखते ही तुम्हें बाइनरी सर्च अगर नहीं चमका तो तुमसे ये क्वेश्चन नहीं हो पाएगा. I'll show you why. This is in the free वाला course also, so you guys can learn it later on. भाई तुम्हें अगर ये सब चीज़ देख के लाइक आइडिया नहीं चमकेगा तो पॉसिबल नहीं है, ठीक है. दिस मीडियन ऑफ सब एरे, इसमें द प्रॉब्लम वाज, इसमें फॉर अ गिवन एरे ऑल सब एरे का सम का मीडियन निकालो, इसमें बस डिस्टिंक्ट का पूछा है. इज द एग्जैक्ट सेम प्रॉब्लम. ये जो क्वेश्चन है इट्स द एग्जैक्ट सेम क्वेश्चन, बस सम के जगह डिस्टिंक्ट पूछा है. द क्वेश्चन इज द स्कोर ऑफ सब एरे इज द सम ऑफ ऑल इंटीजर्स ऑफ सब एरे. ठीक है, फिर सारे सब एरे का निकालो स्कोर एंड फाइंड इट्स मीडियन. सो फाइंडिंग द kth एलिमेंट. सो whenever you get this problem of finding kth element in a n cross n product, कहीं से कुछ हो रहा है, मतलब all I cross j, all ai cross bj, all ai like cross aj, ऐसे कुछ भी जब दो चीज के बीच में क्रॉस प्रोडक्ट होता है ना, all sub arrays, all ij's, all ai aj's, all ai bj's, उसमें तुम्हें क्रिएट प्रोडक्ट निकालना है. दिस इज अ वेरी क्लासिक आइडिया ऑफ बाइनरी सर्च. ठीक है, एंड इसके लिए एक स्टैंडर्ड चेक फंक्शन होता है. प्लीज वॉच दिस फुल कंटेंट एक बार. तुम्हें बाइनरी सर्च कितने लोगों ने कंप्लीट कर लिया भाई, ये मतलब नॉट जस्ट पीपल फ्रॉम एजेड प्रीमियम, बाकी लोगों ने भी कंप्लीट कर रखा है ये चीज पूरा पूरा. तो बहुत नहीं है, बहुत नाइस. ठीक है, तो इसमें बस एक बार ये जो एप्लीकेशन आइडिया ना, एप्लीकेशन आइडिया 3 एक बार वीडियो देख लेना. आई हैव कवर्ड अ वेरी ब्यूटीफुल प्रॉब्लम, दिस kth सम वाला प्रॉब्लम. दिस इज आल्सो वेरी ब्यूटीफुल. ठीक है, ये सब आइडिया जब तक देखा हुआ नहीं है तो फिर फोर्थ प्रॉब्लम सॉल्व करना पॉसिबल है. पीपल कम एंड टेल मी विवेक मेरे से कैसे चमकेगा. भाई देखा हुआ होना चाहिए वो आइडिया, लेजिट वैसा होता है. ठीक है, 80% ऑफ द प्रॉब्लम आई हैव नोन द आइडिया बिफोर. ठीक है, दैट kth in a generation can be found with binary search. Yes, this is freely available. ठीक है, मैंगडोट पे जाओ भाई, रिसोर्स एक्सप्लोर करो थोड़े, उसमें बहुत अच्छे से चीज डाल रहे हैं. आज शायद से एक नेक्स्ट प्रोजेक्ट भी ऐड होने वाला है बहुत अच्छा वाला. तो कुछ चीजें प्रीमियम में है वो भी बहुत अच्छी है, बट जो फ्री में है वो भी अच्छी है. ऐसा नहीं है कि फ्री है तो उसमें कंटेंट में वैल्यू नहीं है. ठीक है, बहुत अच्छी अच्छी कंटेंट ऐड कर रखा है फ्री में, तो उसको एक्सप्लोर करो एक बार. ठीक है, सो दिस इज देयर. और जो तुम बोल रहे हो जो आज जो दूसरा वाला पार्ट है, ठीक है, कि निकालना क्या है क्वेश्चन में आ गया, नंबर ऑफ डिस्टिंक्ट एलिमेंट ऑफ सब एरेज है. ठीक है, सो व्हेन यू चेक कि भाई क्या मेरा लाइक मीडियन x होगा, सो यू नीड टू फाइंड द नंबर ऑफ सब एरेज हैविंग नंबर ऑफ डिस्टिंक्ट ग्रेटर देन इक्वल टू x या लेस देन इक्वल टू x. यार ये भी सेम क्वेश्चन मैंने कल ही या लास्ट वीक ही लाइक क्लास में कवर किया था. मैं वो दिखा देता तुम लोग को. सेम क्वेश्चन. यार क्या कर रहे हो यार, क्वेश्चन सॉल्व करो भाई. नंबर ऑफ सब एरेज विथ हैविंग एट मोस्ट k डिस्टिंक्ट. ठीक है, एग्जैक्ट सेम क्वेश्चन कि फाइंड द नंबर ऑफ सब एरेज विथ हैविंग k डिस्टिंक्ट एलिमेंट्स. ठीक है, यही तुम्हारा बाइनरी सर्च का चेक है. जो बाइनरी सर्च में तुम जो चेक लिखोगे वो यही पीस ऑफ कोड है और कुछ नहीं. जो पीस ऑफ कोड लिखा हुआ है यही है वो चेक बाइनरी सर्च में. सो दिस इज जस्ट अ कॉम्बिनेशन ऑफ टू टेक्निक्स, 2 पॉइंटर्स एंड बाइनरी सर्च. बाइनरी सर्च में kth एलिमेंट निकालने का टेक्निक होता है, वी नीड टू अप्लाई दैट. सो नाउ इट बिकम्स अ चेक ऑफ फाइंड द नंबर ऑफ एलिमेंट्स लेस देन इक्वल टू x, जो होता है ना, मैं बताता हूँ फाइनल. यू विल हैव टू रेफर टू द मटेरियल, मैं पूरा अभी कवर नहीं कर पाऊंगा, सॉरी फॉर दैट, बट लैक ऑफ टाइम, थोड़ा सा 7:30 थोड़ा लिमिट ही है सॉर्ट ऑफ. सो जब भी तुम्हें निकालना होता है kth एलिमेंट, द चेक यू यूज इज नंबर ऑफ एलिमेंट्स greater than, sorry, less than equal to x should be greater than equal to k. तो फिर x can be a feasible thing. तो k का वैल्यू हमारे केस में मीडियन जितना n इंटू एन प्लस 1/2 जो भी होगा वो 4/4 वो बनने वाला है वैसे भी. ठीक है, सो मीडियन का जो भी वैल्यू होता है k वो वाला आएगा k. फिर यू नीड टू जस्ट चेक द नंबर ऑफ एलिमेंट्स लेस देन इक्वल टू x ग्रेटर देन इक्वल टू k. यहाँ पर अगर मैंने कोई वैल्यू डाला d, so number of elements, elements क्या है, how many subarrays have distinct, so number of subarrays having distinct element less than equal to d, ये निकालना है. and you have to check is it greater than equal to k, तो फिर yes या फिर no, बाइनरी सर्च वाला yes no या फिर 0 and 1. ठीक है, ये जो पार्ट है वो एग्जैक्ट ये सेम प्रॉब्लम है. अगेन नंबर ऑफ सबअरे हैविंग एट मोस्ट डिस्टिंक्ट k, बस इसका कोड चेक में जाएगा उसके नीचे बाइनरी सर्च जाएगा, ठीक है। एंड दिस इज अ फेयरली स्टैंडर्ड प्रॉब्लम, ये तुम्हें लीड कोड पे भी मिल जाना चाहिए। नंबर ऑफ सब एरेज विद एट मोस्ट k डिस्टिंक्ट एलिमेंट, दिस इज अ वेरी स्टैंडर्ड 2 पॉइंटर्स प्रॉब्लम। ये 2 पॉइंटर्स में स्लाइडिंग विंडो में क्या होना चाहिए, ठीक है। स्लाइडिंग विंडो में लाइक उसका जो फ्रेमवर्क है उसमें देर आर ओनली लिमिटेड आइडियाज। व्हाट आर द आइडियाज फॉर बाइनरी फॉर स्लाइडिंग विंडो? यू हैव दो टाइप के आइडियाज, वन इज देर आर 2 पॉइंटर्स मूविंग बोथ दीज साइड्स एंड देन देर आर 2 पॉइंटर्स मूविंग दिस साइड, ठीक है। इसमें सिर्फ 3 से 4 क्लासिक आइडियाज आते हैं जो बार बार इंटरव्यूज में पूछते फालतू का। इसमें अच्छे प्रॉब्लम्स बनते हैं, जैसे ये हो गया कि इस विंडो में डिस्टिंक्ट शुड बी लेस देन इक्वल टू के, फाइंड द फाइंड द लेंथ ऑफ फाइंड द सम ऑफ लेंथ ऑफ ऑल सब एरेज हैविंग डिस्टिंक्ट इक्वल टू डी। इस टाइप के प्रॉब्लम्स बहुत सारे बनते हैं, ट्राई करना ये प्रॉब्लम, होमवर्क प्रॉब्लम। फाइंड द नंबर ऑफ सब एरेज हैविंग सम ऑफ लेंथ ऑफ सब एरेज हैविंग डिस्टिंक्ट इक्वल टू डी। अगर पूरा सारे वेरिएशन नहीं पता है तो नहीं कर पाओगे ये प्रॉब्लम, मोस्ट प्रॉब्लम। दिस इज लाइक ट्रू यूज केस ऑफ इट, ठीक है। सो 2 पॉइंटर्स इज लाइक फेयरली इंपॉर्टेंट। इसमें स्लाइडिंग वाले में ये विंडो मेंटेनेंस के ऊपर आइडियाज बनते हैं क्वेश्चन, दिस इज वन फॉर्म, ठीक है। एंड ये सारे मोस्टली बाइनरी सर्च के इजी वाले प्रॉब्लम्स को रिड्यूस कर देते हैं, मतलब जो हर स्टार्ट पे निकालना होता है उसको रिड्यूस करते हैं। दिस एंड देन बाइनरी सर्च का तो अपना फ्रेमवर्क है ही, वो वीडियोस देखो यार एक बार, वो तुम्हें बहुत क्लैरिटी बिल्ड करते हैं, ठीक है। So this should be the idea for the last one. Yeah, do binary search on answer. Once you do binary search on answer, then the check is nothing but find the number of subarrays having distinct less than equal to d, and if it's greater than equal to the number of median elements or not. अब वो check करने के लिए you have to use 2 pointers. ठीक है. Okay. Chandrachud has written the code for the last one, so I'll maybe show you all once. हाँ ये 2 पॉइंटर्स ऐसे लिख सकते हो, दिस इज द चेक में 2 पॉइंटर्स हो गया ये चीज, राइट। द नंबर ऑफ डिस्टिंक्ट इज लेस देन इक्वल टू के लिए, एंड दिस इज बाइनरी सर्च वाला पार्ट। ओके, आई विल सेंड दिस सबमिशन ऑफ Chandrachud, even though I write it in a little different way, 2 pointers मतलब in my classes, because of another reason, because इस टेम्पलेट में कुछ चीज़ें फेल करती है, बट वो शायद अभी तक मतलब डिपेंड, उसको स्पेशली हैंडल करना पड़ता है। बट आई फेल्ट स्टूडेंट समटाइम्स फाइंडिंग इट डिफिकल्ट कि कब चेंज करना पड़ेगा टेम्पलेट को, ये वगैरह वगैरह। इससे अच्छा देयर इज अनदर टेम्पलेट जो भाई हर प्रॉब्लम सॉल्व कर देगा बिना चेंज किए, डेटा स्ट्रक्चर क्लीन कर देगा। इफ आई हैड टू मेक दिस ग्लोबल, वो भी अपने आप काम करेगा सब चीज़ें। थर्ड वन इज ट्रिकी, लेट्स मूव टू थर्ड वन। इसका आइडिया तो मैंने बता दिया है, लेट्स क्विकली डू द थर्ड वन। सॉरी फॉर दिस, 7:30 पे एक्चुअली आई हैव बैक टू बैंगलोर आफ्टर सम टाइम। क्या करके देख रहा हूँ कि विदाउट क्लीनिंग फ्रिज व्रिज यूज़ करने लायक नहीं है, सो क्लीनिंग, घर क्लीनिंग होने वाला है। So I'll have to be there. Sliding window यार, it's lengthier topic, देखते हैं। You are given an array integer n and x, you have to construct an array of positive integer nums of size n where nums of I is greater than nums of I plus, okay, and the result of bitwise addition between all elements of x is x. Minimum possible values of nums of I. Okay. क्या इसमें AZ का नेक्स्ट लाइव, सो इट विल बी इन फ्रॉम मे एंड। नेक्स्ट AZ का जो कोहोर्ट है, मतलब जो प्रॉपर इंटर्नशिप, मतलब एक देयर इज अ कैंप व्हिच इज स्टार्टिंग फ्रॉम 1st of May, इट्स फॉर CF, ठीक है, and it's for a little like people who are starting off right now, like in newbie people region, but जिनको like intern placement क्रैक करने वाला चाहिए, मतलब क्रैक तो यार ऐसे भी हो जाता है कैसे कैसे करके, बट तो कॉन्फिडेंस वाला चाहिए, तो कॉन्फिडेंटली सब क्रैक कर पाए वैसा टाइप का। तो जो कोहोर्ट है वो दैट विल स्टार्ट इन मे एंड, मतलब 25th वाला टाइम पे, इट विल गेट अनाउंस्ड सून। तो वो ज्वाइन कर सकते हो, या फिर जो ऑलरेडी चल रहा है उसमें आज बिट मैनिपुलेशन का क्लास है 8:30. You have to construct an array of positive integers. This number of bitwise and of all elements x minimum possible value of this. तो इसमें क्या करना है, इसमें हमें बस जो बिट्स ऑफ है उनके उसमें नंबर्स जनरेट करने हैं. इंटरेस्टिंग. आई थिंक आई शुड बी एबल टू डू दिस. तो इसमें बस जो x के जो बिट सेट है वो सारे नंबर्स पे होने चाहिए. सो दिस इज गोइंग टू बी नथिंग बट लाइक जैसे सपोज तुम्हें ये दिया गया है, राइट. लेट्स टेक एन एग्जांपल. Yeah, let's take this example. This will be better. Both the examples would be better, I think. ठीक है. So जो नॉन सेट बिट्स है उसमें बस kth नंबर निकाल लो और कुछ नहीं करना है इसमें. Let me show you कैसे सोचना चाहिए इस प्रॉब्लम के बारे में. तो क्या है यार इतना बड़ा क्यों है ना. आउटपुट 6 एक्सप्लेनेशन अपने को बाद में लिखना है. ठीक है. So what we are looking for is the and of all numbers should be equal to the x. ठीक है. तो and अगर x है तो all numbers should have x in its mask. So x is 4. So 1 0 0 1 0 0 तो सब में होगा. Now these are the free bits. ठीक है. These are the free bits. और ऊपर में जो bits है कि इस पे तुम 0 डालो और 1 डालो, you are free. ठीक है. So now what we will do is we will start. जैसे अब हमें जैसे अगर 3 नंबर बनाना है जिनमें ये 1 होगा because the and has to be 4 and these are free. So what we will do is we will keep one of the numbers like this ताकि and इससे तो छोटा ही हो, right? Because and of all the numbers is always less than the smallest number. Okay, and always reduces the number. And क्योंकि सब में ये है तो and exactly equal to ये होगा. Okay, for x. But now I'll try to put 1 over here, then 1 0 over here, then 1 1 over here, then 1 0 0 over here, then 1 0 1 over here. ठीक है. If I have to keep generating numbers, this is how I'll generate. कि ये जो bits है जिस पे 1 रहना चाहिए by the virtue of x, I'll keep it constantly x 1. Rest the bits that are free, I'll generate that as 0 0 1 1 1, 1 0 0 1 0 1, then 1 1 1, then 1 0 0 0 ऐसे करके जनरेट करूंगा जितने नंबर जनरेट करने पड़े. Right? So if I have to like so say here they are saying that I have to generate the third number, right? So this is 0 1 2. तो 2 के इक्विवेलेंट बिट लिखो 1 0 और उनको इस बिट्स को छोड़ के बाकी बिट्स में प्लेस कर दो, राइट, इन बिट्स में. सो दिस इज 1 0 ओवर हियर. सो द आंसर विल बी 6. जैसे यहाँ पर क्या लिखा हुआ है, x is equal to 7 एंड सेकेंड नंबर. सो n minus 1 जो नंबर होता है 1, 1 को बिट्स में लिखो, इट्स जस्ट 1, राइट. So I have to place 1 in the free bits of 7. Free bits of 7 क्या है? 7 तो यार 1 1 1 है, तो नीचे कोई free bit नहीं है, ऊपर ही है. So I have to put 1 in the free bits of 7. So I'll put here. So this is whatever this number is, 15. It will be my answer. So for every number that is given to us x, I'll find the free bit positions, and the number that is given to me in n, I'll do n minus 1 because ये 0 से स्टार्ट होगा इधर 0 1 2 like when I'll put things there. This is a constructive problem to some degree, but 0 1 2 put करूंगा, so 2 के लिए 2 put कर दूंगा in free bits में. So if the for example if x is equal to 5 and n is equal to 4, so what will I do? X is 5, so I'll write 5 1 0 1. यहाँ से bit start हो रहा है. So this is free, this is free, this is free. n is equal to 4, so 4 minus 1 is 3. 3 is nothing but 1 1 0 0 0. So I have to put 1 1 in this, so I'll put 1 here 1 here. So the number is 15. Answer is 15 in this case. यही करना था ना चंद्रचूड़ शायद, if I'm not wrong. कंफर्म कर दिया करो भाई, मैंने सॉल्यूशन तो नहीं देखा, श्योर नहीं. गलत तो नहीं सोचना चाहिए आइडियली मुझे, बट स्टिल कहीं कुछ गलत बता दिया तो बता देना. लेट्स सी चंद्रचूड़ कोड. building the answer. So you have built the अच्छा n-1 का bit string, इसका bit string. Okay. So जो zero है वो बस skip हो जाएगा essentially. If this is one, then it just gets skipped, or else we just copy paste everything from lowest bit to highest bit. Perfect. And the next batch is starting from 25th of May. You guys will get to. I'll post it somewhere जब भी वो start हो. Don't worry. ठीक है. Be on the Telegram या फिर on LinkedIn. I'll Telegram पे. If not, I'll post it whenever it gets started. I don't rush on starting new batches. Already जितने students आते हैं वो लोग को पहले अच्छे से कराना है. That is goal. So जल्दी जल्दी बैच स्टार्ट करने का कोई मोटिवेशन नहीं है. अभी कैंप में भी अच्छे से करना है, प्लस बैचेस में तो करेंगे. ठीक है. सो अभी तो जैसे जुलाई अगस्त में इंटर्नशिप प्लेसमेंट, सो लॉट ऑफ पीपल आर लुकिंग फॉरवर्ड टू दैट. सो अभी उनके लिए अभी अच्छे से उनका भी प्रेप चल रहा है अच्छा ऑलरेडी. देयर हैज टू बी रिगरस प्रेप. ठीक है. आई मीन कैंप, आई जॉइन इज एज वेल. यस, वर्क्स. ठीक है. देन आई थिंक वी हैव कवर्ड ऑलमोस्ट ऑल. नाउ in the next, so the ones that are like both weekly bi-weekly थोड़ा lengthy हो जाता है, but I think वो DP वाला problem was the hardest and was most important, so we covered that extensively. ठीक है. So go through that and solve the problems in the Leetcode 2 contest, so that will give you guys a lot of clarity. Okay. Yeah, that will help as well. So they are both of two different goal. मुझे थोड़ा like बार-बार लोग ये पूछ रहे हैं. I'll make it very very clear. If your target is always intern placement, so the premium batch is for you. If your target is CF पे rating boost till 1400 or even 1500, a little bit can be done, but 1550, 14, 1500, तो the summer camp is for you. Target oriented होना चाहिए. And people come and tell me कि विवेक दोनों का target तो same ही है. CF पे rating बढ़ जाएगा तो क्या intern placement हो जाएगा? It's same thing. आई फील नो दैट, मतलब मैंने जितना देखा है, जितने टेस्ट आ रहे हैं और जैसे प्रेप करना पड़ता है, दे आर टू डिफरेंट थिंग्स. ठीक है. सो द प्रेप इज वेरी डिफरेंट. जैसे 15th of May से देयर इज बूट कैम्प स्टार्टिंग. सो कोर CS वगैरह पढ़ना हो गया, ये सब चीज़ें हो गई. सो जिनका जुलाई में, उनके लिए तो फिर अभी मई से ही स्टार्ट करना पड़ता है. आई डोंट थिंक 4-5 मंथ के प्रेप से पहले कंप्लीट होता है चीज़ें अच्छे से. हाँ, यस, 4-5 मंथ्स ऑफ मोर देन. समर्स अच्छे से यूज करना है. ठीक है. Cool. चलो फिर आई थिंक विल डिस्कस नेक्स्ट लीड कोड ऑल्सो. एंड अगर कुछ और रहा तो यू गाइस कैन पोस्ट मी अप फ्रीली ऑन लिंक्डइन एंड ऑल. बट जैसे अभी हम लोग सोच रहे हैं कि कोड फोर्सेस भी स्टार्ट करेंगे विद समर कैंप. सो फॉर यू गाइस देन PCD ऑफ कोड फोर्सेस राउंड्स विल ऑल्सो बी नाउ हियर. दैट्स अ अपग्रेडेशन ऑन द चैनल. अभी तो बस लीड कोड हो रहा था. अब CF के भी एड ऑफ आइडियाज डिस्कस करेंगे कि हाउ टू थिंक एंड एक्चुअली कम अक्रॉस इट. ठीक है. एंड CF पे भी लाइक देयर इज इनफ पैटर्न्स. आई वाज एक्चुअली गोइंग थ्रू इट कि यार BCs जो आ रहे हैं वो क्यों नहीं बन रहे लोगों से. एंड देयर इज सम अमाउंट ऑफ स्टडी आई हैव डन, सो लर्न दैट इन द कैंप. ठीक है. चलो, कूल. This will be it for now. Thanks for joining in, everyone. I hope this was something fruitful for you all. We will next discuss the next round on next Sunday as usual. Till then, keep learning, keep coding, right? And enjoy the process. Okay? Bye bye. See you all. And like कर देना यार stream को, अभी तक नहीं किया तो. DAC on tree. GSC on tree यार YouTube पे मैंने बेसिक सा पढ़ाया था, but I think the CF blog is really good on DAC on tree. So you can. Okay. DAC on tree का CF का जो blog ही है वही है DAC on tree. और क्या? I have not done it from any other place. The blog should be it. I learned it from this only. जब मैंने ये कोड उठा लिया था और फिर मैं बैठ के कुछ क्वेश्चन सॉल्व कर रहा था यहाँ से. So that's how I learned DAC on tree वैसे तो. But DAC on tree is a fairly interesting idea, and इसके questions आते हैं. So DAC on tree is one. Euler-Tor and segmentary is another idea. So these two things is fairly important. DAC on tree मैंने अपने YouTube पे एक बार cover कर रखा है, if I remember correctly. जस्ट द फंडामेंटल आइडिया कि होता क्या है डीएससी ऑन ट्री। जब मैं यूनियन फाइंड नहीं कवर करा तब मैंने कवर करा था, इफ आई रिमेंबर करेक्टली, बहुत पहले चला गया। यूनियन फाइंड डीपी के बाद करा था क्या मैंने? मुझे अपनी वीडियोस ही नहीं मिल रही। डीएससी, ये डीएससी ऑन ट्री, दिस इज वन थिंग यू कैन अंडरस्टैंड, मतलब अगर पूरा आइडिया समझना है तो दिस इज समथिंग यू कैन गो थ्रू, तो दिस विल गेट इट फुल्ली क्लियर कि ये काम कैसे कर रहा है। एंड देन आई हैव मेंशन्ड दिस ब्लॉग आल्सो। ये है ना, ये वीडियो बना तो रखा है, पढ़ा तो रखा है यहाँ पर। मतलब कंसेप्ट पढ़ाया था, क्वेश्चंस नहीं प्रैक्टिस कराया, बट एनीवेज क्वेश्चंस शुड बी द वंस दैट आर ओवर हियर। या वी कैन डू सम प्रॉब्लम सॉल्विंग सेशन आल्सो ऑफ डीएससी ऑन ट्री, क्वेश्चंस कैसे सॉल्व करना है सोचे कैसे, समडे। अभी तो नहीं, अभी बहुत सारी चीजें, अभी मुझे कैंप पूरा सेट करके अभी स्टार्ट करना है। इट्स लाइक माय गोल फॉर द नेक्स्ट 3 days। सेट ही है चीजें, काफी सारी चीजें, बट स्टिल फाइनल फ्यू थिंग्स आर लेफ्ट, सो दैट्स माय गोल अभी के लिए। उसके बाद विल मे बी डिस्कस मोर थिंग्स। प्लस सी एस का मैंने लाइक डाला ही है टेलीग्राम पे अनाउंसमेंट, वो देख लेना, तो स्टार्ट होगा ही फॉर श्योर। ठीक है, so that will be also very interesting. Chalo then, that will be all for now. Thanks for joining in. Bye bye. भाई को एनरोल कराया, गुड। चलो ठीक है, चलो बाय बाय।